All right, this is Unit 1 for Pre-Algebra Probability. This is your study guide video. So in class, you should have received a paper copy of your study guide. This area right here is just for you to use to create your sample space. That is its only purpose. So let's get started. Question number 1, what is the sample space for the shown cards if a card is drawn at random, replaced in the deck, and a card is again drawn at random? List the sample space. So we have 4 cards. You pull one, you put it back, and then you pull another one. We need to list the sample space. So the way that we did this in class was we put headers up at the top, and then we created our lists. This is an example of what my list looks like. We had 4 cards, and we pulled 2 times, so we ended up with 16 outcomes. Question number 2, draw a tree diagram to represent the sample space for flipping a game piece 2 times with green on one side and red on the other side, then list the outcomes. Okay, so if we have a coin and we have our first flip, say for example, we get a green, okay? On our second flip, you could get green or red. So to list those possibilities, my possible outcomes, I either have green, green or green, red. Now, what if on my first flip, I got red? Sorry, used to heads and tails. What if my first flip was red? Well, then my second flip from there could either be green or red. So my outcomes here would be red and then green, or red and then red. Here I have 4 possible outcomes, and that would be my answer. Fill in the table to represent the sample space for the repeated event. The representation of the sample space will be row. So your rows are what go across horizontally. And then you're going to list the columns. So the second letter or the second, that you should list would be the ones coming from the columns, which go up and down or vertical. So we have yellow. So we would have YY, BY, RY. Then we would go to our blue column, YB, BB, RB. And then our red column, YR, BR, and RR. When you have to do this on the FAST, if they are specific about how they want the rows or the columns, be sure that you are listing it correctly and that you know what a row is and what a column is. What is the theoretical probability of rolling a 10-sided die twice? So you have a 10-sided die, you're going to roll it 2 times, and rolling an odd number each time. So first we're going to figure out the denominator for our theoretical probability. So I'm going to take that 10-sided die, and because I'm going to be rolling it 2 times, I have 10 times 10, which is 100. And what is the odds of rolling an odd number each time? Well, here's the table of our 10-sided die, and an odd number each time are all the ones highlighted in pink, or I could create a list down here as well. I still should end up with the same result, and that is 25 out of 100. And here they want you to answer in fraction form. Well, this is a fraction, simplest fraction form. So we need to simplify 25 over 100, which simplifies to 1 over 4. And they also want it as a percent. So 1 divided by 4 is 0.25. To make that a percent, we're going to multiply by 100, and we get 25%. All right, question number 5. There are 6 marbles in a bag, 2 pink, 1 blue, and 3 orange. What is the theoretical probability of choosing 2 pink marbles with replacement? Round your answer to the nearest whole number. So percent. So we have 6 marbles in a bag, and we're going to be choosing 2 marbles from that bag with replacement. So first thing we're going to do is figure out the denominator for our fraction of our theoretical probability, which is 6 times 6, so 36. Then we're going to figure out how many times we could pull a pink or the same color, choosing 2 pink marbles. So if we look at our sample space for this scenario, we have 4 boxes where we have 2 pink marbles. So 4 over 36 which simplifies to the decimal 0.11, and that is a continuing decimal. Multiply that by 100 and we get 11%. Question number 6, we have a set of cards where we have an ace, a king, a queen, and a jack. What is the theoretical probability of pulling an A 2 times in a row? So we have 4 cards. We're going to pull 2 times, so 4 times 4 is 16, so that's the denominator of our fraction for our theoretical probability. And if you look at our sample space for this scenario, we can only pull an A 2 times 1 time. So our fraction would be 1 over 16. And we can leave it as that because it's already simplified. All right, question number 7. Determine the theoretical probability of rolling a number greater than or equal to a 3 on 2 rolls on a 6-sided die. So here's the sample space for a 6-sided die. We've done that quite a bit in class at this point. But really what it's asking you to find is where it says on 2 rolls, it means that it wants the number 3 to be on the die for both rolls. So I don't like the way that this question is worded. So both die would need to be 3 or higher. So our denominator first, we have a 6-sided die, 6 times 6, 36. Well, if we're looking for the number that is greater than or equal to a 3, both rolls, that's going to be this right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is 16 over 36. And then we can simplify that even further, which I forgot to put on the notes. So 16 over 36 is going to simplify to 4/9. So I'm just going to write that in here. 4/9 is the simplified fraction for that. All right. Now that I can turn that off. So if Penny spins the spinner shown 420 times, so she's spinning this spinner 420 times, what is the reasonable prediction of how many times she will land on 6? So 420 is going to be what we're multiplying by once we have the theoretical probability. So how many times will she land on 6 if this is her given spinner? Well, we have a 6 here and a 6 here. So 2 out of 12, because there are 12 sections on this spinner. So 2 over 12 multiplied by 420 is equal to 70. All right, question number 9. A bag contains 3 marbles, red, blue, and green. A repeated experiment of drawing a marble at random 80 times with replacement is shown in the table below. Based on the table, what is the experimental probability that a blue marble and then a green marble, so blue and then green, will be drawn? Write your answer as a percent. So here in the table, it shows blue and then green, and there's 15. So that's where the 15 came from. And then we have the 80 because they did the experiment 80 times. So 15 divided by 80 is equal to 0.1875. To make that into a decimal, we're going to multiply by 100, and we get 18.75%. But it says to round your percent to the nearest tenth. Okay, so when we're rounding this to the nearest tenth, because it's 5 or more, we're actually going to change that to 18.8%. Question number 10. A coin is flipped 3 times as an experiment. The theoretical probability of a coin landing on tails at least 2 times is 0.5. So they're giving you the theoretical probability. If the experiment is repeated 300 times for 900 flips, and this can be ignored, we don't care about that. We're really only looking at how many times the experiment was done, which is 300. Predict the number of times landing on at least 2 tails. So that is 150, because all we had to do was multiply 0.5 or 1/2, multiply that by 300, and we got 150. All right, last question. Miss Anuez rolls a 6-sided die at the end of every class. If she rolls an odd number, the student's homework gets cut in half. If she rolls the die every day in the 200-day school year, how many times will the students predict, should the students predict that they will have their homework cut in half? So on a six-sided die, there are three odd numbers, 1, 3, and 5. Okay, so the possibilities of rolling a 1, 3, or 5 is 3 out of 6 because it's a six-sided die. If she rolls the die every day in the 200-day school year, so we're going to take that 3 over 6 and multiply that times 200, and we get 100. So it could possibly happen 100 times. That's it. Good luck on your test.